Hello, I'm Christopher, a research software engineer with Research Software Workshops, and it's a very warm welcome to part 5 of Intermediate R. Now all of the material is here at chriswoods.com/intermediate R, and now we're on to the section data.frame. Now R is a statistical programming language, and it was designed primarily for data analysis and data visualization. Now key to this is inbuilt support for tables of data. Now a table of data in R is called a data frame. A table has columns, which are given names, and there are rows, which contains data for each column. Now for example, let us now create a table that contains animals and their sounds. Now we create a table by first choosing the variable we're going to assign it to, which we'll call pets, and then data.frame is then going to enable us to create the data, the actual table of data. Now first we need to put in the animal. So the name, the column name is animal, and then we're going to put the value for that column. So in that case we're going to have cat, dog, bird. Next we're then going to put the next column, which is sound, and for that we're going to put in meow, woof, and then tweet. So we now hit return. We can now see here in the environment, I'm just going to move this down, we have pets, where we can have two columns, and you can see when I click on the environment you can see these two. We have the column animal, which has the values cat, dog and bird, and then the column sound, which has the values meow, woof and tweet. So effectively there's row 1, row 2 and row 3 of this data. Now this has created the data frame with two columns. There are 3 rows, and indeed as well as clicking on the environment to see it, we can also just print the data. So we print pets, you can see it's put here, or indeed I can just type pets and hit return, and again we can see it as well. So there are 2 columns, one named animal, one named sound, and then here are the values for those 2 columns. Now you can access a column in the table using a $sign followed by the column name. So if I type pets, then the $sign, and I want the animal column, and hit return, you can now see here we have the animal column, cat, dog, bird. Equally, we can get the sound by doing pets, $sound, meow, woof, tweet. Now you can also use the index of the column. So the very first column is animal. This is at column 1. So pets index 1, remember we use square brackets for index, has returned the first column, which is the animal column, whereas pets column 2 would index the second column. Now doing it like this, it's actually returned to us a new data frame, hence why this now looks like a 1-column data frame. If we want just the data itself, then we use double square brackets. Double square brackets means just return the underlying list, the underlying vector that holds the data. So there is the underlying list that contains the sounds, meow, woof, tweet, and here with double square bracket 1 we now get the underlying list, cat, dog, bird, which had column 1, which was the animal. I'm just going to clear this and then type pets again so we can just remember where we are. Now to get a row, so this was how we got a column, let's say we want the first row, we do that by using square brackets again, but instead of doing 1 on its own, which would mean get the first column, if we do 1 comma, that would mean get the first row, hence we can see cat, meow. Equally if I do pets 2 comma, we now get dog, woof, etc. And then if you want a specific row and column, then we pass in the row and column number. So 1, 1 would mean give me the first row, first column, which is cat, whereas pets 1, 2 would give me the first row, second column, which would be meow. Now, so far we've placed this data into a table by typing it by hand. So if I just go up in my history, we can see here, where are we? There we are. We created the data frame manually by typing the data in by hand. Now, that is not how you would normally be working with data frames or large amounts of data, because if you had to type it like this, your fingers would fall off. Instead, what we tend to do is we tend to read data from a data file. Now, Data can be formatted in lots of different ways, and R has many different methods of being able to read data into a file, but the most popular way of reading things is to use read CSV for data which is CSV formatted. So I'm just going to clear this. We've moved now down to here in the material, and we have an example data set here, which is the cats data set, which is available as a CSV file. If I click on this, this is the information about the data set, and indeed we formatted it for you, so it's available at this web page. And again, I'm just going to have a quick look at it so you can see what it is. So here we have the data file. The data file is comma separated, so there are 3 columns: sex, body weight and heart weight, and then each column, each row is then written as a line with the columns separated by commas. This way of separating out data using commas is very common. Commas are very common. Hence why it's called a comma separated file, or CSV value file, comma separated values. Now we can read this data into a data frame by using the read.csv function. Now this function could take in a file name, but equally you can actually pass in a URL that contains the data. So remember, this was the URL that contained the data. I must put this in double quotes, so I'm going to do that now. And now if I hit return, what's happened is it's gone and it actually loaded that data from the internet and loaded it into a data frame. We can see there's 144 observations of 3 variables. I double click on it. There we are. We can see there's our sex, body weight, heart weight. All the data has been read in very nicely. And indeed, if I now type here, cats, you can see there is the cats printed to the screen. So this brings us into our exercise. What I'd like you to do is I'd like you to read the cats dataset into a data frame. Look at what the 3 columns are and play with them. And remember, you can use cats $ to be able to sort of play with things and see what there is. And then I want you to use the calculate mean and calculate max functions that you wrote in the last section to basically calculate the mean and maximum body weight and heart weight of the cats. So I'm going to let you press pause now, and when you come back from pause, I will show you the answer. Okay, you've now come back from pause, so you're now ready to see the answer. So I'm just going to come back here, and so we have the cats data set. And what we can do is we've loaded the cats data set up, just to remind yourselves, it was cats is assigned from read.csv, and then the name, the path to the actual file. There we are. Nice all on one screen. I've just read that again. And now if I type cats and then $, what you'll see immediately is RStudio's noticed that here we have the 3 columns and it's popped them up. So it enables us to basically choose one of the columns that we wish. So this is the list of all of the sexes of the cats. Now the next part of the exercise was to basically use our function, which was our calculate max and calculate min. So let's go back in our history to find our calculate max and calculate min, just to make sure they're still there. So there's our calculate max, so I'll make sure it's in the system. And then I'm going to make sure I've got my calculate mean as well. That's our calculate max, and here's our calculate mean, so those 2 functions are definitely there. So if we want to now calculate the mean of the heart weight and the body weight, let's now do that. So we're going to say mean heart weight is assigned from calculate mean, and then we're going to take cats, and then we want to get the heart weight. Then we want the mean body weight. So mean body weight is assigned from calculate mean of cats $, and then we're going to put the heart weight. And then we now want the max heart weight. And notice there that was an error. That should have been body weight, not heart rate. Always sort of double check what you're typing. Now we're going to do max heart rate is assigned from calculate max now of cats heart weight. There we are. And then max body weight is assigned from calculate max of cat's body weight. And then let's print this to the screen. So let's do cat sprintf heart weight. If I can type, typing is always difficult, particularly live. Mean equals %.2f, and then max equals %.2f. New line. Let's do that, and then put in the two values. Well, it was mean heart weight, and then there was max heart weight. There we are. So mean was 10.63, max was 20.5, and now let's do the same thing for the body weight. Cat sprintf. Body weight colon mean equals %.2f, max equals %.2f as well. New line, and then we're going to pass in mean body weight and max body weight. And now we find the mean is 2.72 and the max is 3.9. So if you didn't have your calculate mean and calculate max in your session because you'd restarted, just copy those from the previous section. But otherwise, that's how you then complete that exercise. So that's now completed all of the exercises in this part of the workshop. So now we've completed part 5. You're now ready to move on to part 6, where we're finally going to be working on the tidyverse. I know many of you are looking forward to that. So I'll see you in part 6.